When you hear the word inverse, what other word can you think that describes that? Inverse, opposite, right? It's a lot like the opposite. Now, in math, operations have inverses. Like if you add something, what's the inverse of that? Or the subtract. Or if you divide, what's the opposite? Times or multiply. So you guys are used to that when you're solving for equations. You're doing the opposite or the inverse operation. Well, functions also have an inverse. We're gonna talk about how to find those. So what I want you to do in this column, and leave some space off to the right because you're gonna make another column over here. If you didn't already. Sounds like you didn't, but that's okay. This column right here, it's kind of like an order of operations column. If you were to plug a number into x, according to order of operations, what's the first thing that would happen to this x? Be multiplied by 2, right? These aren't hard questions I'm going to be asking you guys. Pay attention. The first thing that happens to x is multiply. Multiply by 2. Chelsea. Come on. Only one other thing that would happen to it here. After you multiply by 2, what would happen to the x? Then subtract 1. So this is like your order of operations column. It's just because it's this function here. It's 2x minus 1. So these are the steps that describe this function. Now, on the other side of this, we're going to make a column. And I want you to put this right here, 2x minus 1. What if we turn this function into an equation that we could solve? Instead of f of x equals 2x minus 1, what if it were 2x1 equals 0? Over here on this column, I want to write down the steps you would do to solve this equation. What is it? You would add 1 and then divide. By 2. Those are the only two steps we would need, right, to solve the equation. Do you notice any connection between the first column on the left and the column on the right? They're opposite operations, and the order has switched, right? So here on the left, we started by multiplying by 2, and then we subtracted 1. But when we're solving the equation, we added 1 and then divided by 2. You guys have been actually studying inverses since you learned how to solve equations. You just never thought of it as inverses. Now, look at this, you guys. One other thing I want you to do. 2x minus 1, we were able to describe that using words here. Could we make a function using these phrases? So if we started, let's make a new function here. If we started with x, according to this phrase here, what's the first thing that would happen to x? We would add 1, and then what's the next thing that would happen to it? Divide by 2. So I want you to write this down. What do you think the relationship is between this new function that we made up here and the function we started with? It's the opposite. And what's another word for opposite? So this is the inverse. This is the original function. This is the inverse function. That's the relationship here. The relationship is it's opposite operations, and it's also in the opposite order. Now I want you to write this. F, since we started with function f, we're going to write f. But since we found the inverse, you have to put this little symbol on it, f to the negative 1. This little symbol means inverse. This little symbol right here, f to the negative 1, that means we found the inverse. Now draw this line right here between the two functions. I want to make sure you're clear in your notes on the relationship. The relationship here is that these are inverse functions. What's the importance of the inverse function? What does it describe? It describes the steps you would take to solve the equation, right? If the equation were 2x minus 1 equals 0, the steps are add 1 and then divide by 2. So that's the significance of the inverse of a function. Okay? Now, there is a much quicker, much easier way to find a function rather than having to list all the steps and then do the opposite of the steps. Much quicker way. Would you be interested in that way? Write this phrase down. And honestly, most students get good enough at this that you just look at the function and automatically know what the inverse is going to be. Because it is kind of a simple thing we're doing here. Notice the phrase I underlined. That's important to remember. Whenever you see the word inverse, that's the phrase that should pop into your head. Switch the place of x and y. That will be helpful to remember for the test. Switch the place of x and y, and then solve for y. That basically means get y by itself. So, let's take a look at the exact same function we started with, but let's use this new method to find the inverse. So y equals y equals 2x minus 1. Well, what's the first step? What does it say to do here? Switch the place of x and y. That's a pretty easy thing to do. Just take the x and the y and flip-flop where they are. Not so complicated, right? Well, just the x. So x equals 2y minus 1. All you do is you take the variables, you leave everything else alone, all the numbers you leave alone, you just take the variables and flip their places. And then the very last thing is, what does it mean again to solve for y? You get y by itself. Now take a look at this. What's the first thing you would do here to get y by itself? Add 1 and then, does that sound familiar? Add 1 and then divide by 2. Haven't we seen that before? So we would add 1 to both sides. That leaves us with x plus 1 equals 2y. And divide by 2. It is. So that's probably a little quicker way to find an inverse. You switch the place of x and y, and then solve for y. Now I want you to go back up to this middle step here, and put something in parentheses. Yeah, this is the answer. We're done with this. This is it. Now, you notice on this middle step, if I divided this side by 2, I divided the entire side all at once just by putting a big line. That's how most people will do it, and this is fine. That's just how I would do it. On rare occasions, you'd want to do this a slightly different way. So in parentheses here, put this. Go back up to that middle step. X plus 1 equals 2y. Sometimes you're going to want to do it like this. Divide by 2, right? On the right side. But instead of dividing everything all at once by 2, individually divide them by 2. And you're going to end up with this. 2 divided by 2 in front of the y, they cancel out. So y equals x divided by 2. I'm going to write it like this. 1/2 x plus 1/2. X divided by 2 is the same thing as 1/2 times x. The reason for this, does anybody recognize this type of equation as it pertains maybe to graphing? Y equals mx plus b. So if they're asking you to graph the inverse, which they're going to do at the end of the assignment, it might make more sense to divide everything individually, because then you end up with mx plus b form. But most of the time, I would say 90% of the time, just divide everything all at once. Much quicker. Okay? All right. Example 2. Got to move quick, guys. There we go. To find the inverse, you have to switch x and y, but there's no y on here. But say that again, what you just said. Come on. F of x is the same as y equals, isn't it? So just pretend that the f of x is a y and start the same way. Switch their places. Yeah, just use y. No, I meant bunk her on the head, not tap her nicely on the shoulder. Oh, okay. Anyway. Inverse. Yeah, that's okay. Switch the place of x and y. That's the same first step as the last problem, right? The second step is the same. You solve for y. Now this one, a little bit trickier, but not much. What'd you do first? Add the 3. So that's gonna, let's see, we're gonna have x plus 3. You're right on the nose there. Well, you could do that, but we could actually take care of the entire 2/3 in one step. You should have learned back in Algebra 1 what to do here. This is an algebra. Exactly. Good, you guys remember pretty well. I'm surprised. Actually, I'm not surprised. You guys are smart. My other classes aren't so much. No. They're probably going to listen to this. No, other classes, you guys are fine. Say that again. Chelsea, you were saying something. Multiply by reciprocal. What does that mean? Flip the fraction over. Exactly. If you want to get rid of a fraction that's right in front of a variable, you can multiply by the reciprocal. Why does this work, though? Because? There you go. Very good. Because you get 6 over 6 in this case, which is just 1. That's why that works. But if you multiply on one side by the reciprocal, you have to multiply the entire other side by the same thing, the reciprocal. Oh, yeah. So what do you normally do with a number in front of parentheses? You're going to do the same thing here. Distribute. 3/2 times x is just 3/2 x. Yep. Yep. And then, good. Very good. Yep. 3/2 times 3 is 9/2. Now the y is all by itself, so we're done. But there is one thing I want you guys to be careful of. We started with function notation, yes? So we need to end with function notation. And it's not going to be f of x because that was the original function. What's the inverse of f? F to the negative 1. There you go. Very good. If you start with function notation, you need to end in function notation. All right. We're going to do one more quick one, and then we're going to give you about 15 minutes to work on your assignment. The assignment's short. It only has like 13 problems. There's one more section we're going to get to after that 10 minutes of working on the assignment. Here's example 3. Same directions. Find the inverse. Actually, I want to practice some of you guys real quick. Everybody put your pencils down. Freeze, 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 freeze. I want you to kind of practice looking at a function and then in your mind trying to decide what the inverse is going to be, because for this one it's really easy to do. Take a look at what I'm circling. If you have x, the first thing you would do is add 1 and then divide by 4. So do everything now in the reverse order. What's the reverse order? You would take x and times it by 4, right? And then minus 1. Well, you just found the inverse. Because you're doing everything in the exact opposite order. You see what I mean? If you get good enough and you know what you're doing, then you can decide on what the inverse is going to be without having to do much. But for this one, we're still going to go through the steps. What's the first step to find an inverse? Switch the x and the y. So this is the y, this is the x. Switch their places. Well, it is, but we're going to go through all the steps here. X equals y plus 1 all over 4. Now we got to get y by itself. So would we want to subtract 1 first or divide or multiply by 4? We want to get rid of this fraction. So multiply both sides by 4. Because now dividing by 4 and multiplying by 4, then you subtract the 1. So we get 4x. No, they're not like terms. Subtract 1, and then we get 4x minus 1. And it doesn't equal y, it equals f to the negative 1. Because that means inverse of f. Okay, let me hand out the problems I want you to do. This is like number 9, starting number 9 of your worksheet. So to show the two functions are inverses of each other, here's what you do. You have to take one of the functions, plug it completely inside. We did this on 6.1, right? What is this called? Starts with the C. Composition. There you go. If you take the composition of the two functions, everything should cancel out except for an x. That's what should happen. That's what this means. If you take the composition except for x, that's what should happen. So, and before we show that, doesn't that kind of make sense? If you take the inverse of a function and put it inside the function, the inverse describes the steps you would take to get rid of all the numbers, right? So what should be left? Just x. So that hopefully will make sense to you guys. If you do the inverse of a function inside the function, everything cancels. So let's take a look. We're taking the g function and putting it completely inside of function f. So function f is right here, 3x minus 2. What's going to happen with the x? Open parenthesis, yep. And then what, Jordan, what goes in the parenthesis? Good. The g function, which is x plus 2 over 3. This is what we did on 6.1. We're finding the composition. Now, this x plus 2 is being divided by 3, but it's also being multiplied by 3. So what's the deal there? They just cancel out. And that leaves you with x plus 2 minus 2. But now what happens? Now the plus 2 and the minus 2 cancel, and what does it equal? Isn't that what it should, like we described up here, the composition should equal x. And does it equal x? Yes. Now, you actually have to show both ways. In order for it to be inverse functions, both part A and part B have to work. Sometimes you'll try one way and it equals x, and if you try it the other way, it won't equal x. That means they're not inverses. So both ways have to work. If they both don't work, then they're not inverses of each other. Not inverses, yep. So let's try it on this one. We're taking the f function this time and putting it inside the g function. So look up at the g function, g of x. This x should be an empty parenthesis. So parenthesis plus 2 all over 3. What goes in the open parenthesis? Yep, 3x minus 2, the f function. Well, we got to make sure that we do this in the right order. We can't cancel the 3's yet. Okay. Now, if there's nothing to distribute and there's no exponent, there's really no need for these parentheses anymore, so I'm just going to erase them. What's going to actually cancel first? The 2's, the negative 2 and the plus 2. So that's going to give you 3x over 3. And then the 3's 3 divided by 3 is just 1. So what does this equal? X. So we checked both cases. They both equal x. What does that mean about these two functions? They're inverses. That's how you show. So that's how you do number 9 and 10. Now, the very last 4 problems, turn your worksheet over to the back side. You see the graphs? Let's work number 12 together as a class. So you can actually do this set of notes on your worksheet. The directions say to graph the function, but then find the inverse and graph the inverse. So we got to hurry. We got 5 minutes. And this is easy stuff. This is like Algebra 1 graphing. How do you graph a straight line? Exactly. Well, does the negative 2 go on the x-axis or the y? The y-axis. Good. This is called the Y-intercept. Yep. And this is called the slope. You guys remember this. You love this? How do you use the slope of negative 2, though? Down 2 and over 1. Good. Because there's really a 1 underneath that. So it's negative 2 over 1. So down 2 over 1. Now we've graphed that line. The inverse will be just as easy to graph. Man, I didn't even hit those points. Oh, that's the first line. Now we got to find the inverse. No shading on this. Okay. What's the steps to find the inverse? You switch. We're going to do that, yeah. First we switch x and y. X equals negative 2y minus 2. Write quickly, you guys. And then what? Add 2, yep. Add 2 and add 2. So that's going to leave us x plus 2 equals. Now remember when we're graphing, you might want to divide each term separately. Remember that? So divide by negative 2. Oh man, come on. Divide by negative 2 each term separately. So the inverse is going to be y equals negative 1/2 x minus 1. X divided by negative 2 is the same as negative 1/2 x. And then 2 divided by negative 2 is negative 1. So you start at negative 1, right? And then you go down 1 and over 2. Oh, geez, that was terrible. Let's see if... Man, I am struggling with my lines. That's better. Now, real quick before the bell rings, you guys, let me show you an alternate method that you might like. You see where my arrow's pointing to that point? What's the coordinate of that point? Quick, quick, quick. No, what's the coordinate of the point? 0, comma. Okay, what's the coordinate of this point right here? 1, comma, negative 4. Now, I know the bell is going to ring, but stick around for just a second. If I were to switch the x and y of this point, what would you get? Negative 2, comma, 0. Well, check this out. On the inverse graph, negative 2, comma, 0 is on the graph. Because you switch what? You switch x and y to find the inverse, right? Now, this point right here, the 1, comma, negative 4, what would you get if you switched x and y there? negative 4 comma 1. So take a look at the inverse graph. Negative 4 comma 1 is on the graph. So I know we kind of rushed through that, but if you start with the graph of a function, what's an easy way to find the inverse? You take a couple of points on the graph, you switch x and y, that'll give you points on the inverse graph. Did you guys catch that? Nope, that works every time. That works every time.